Hello and welcome. Today we'll be doing a construct the NPDA problem from the textbook An Introduction to Formal Languages and Automata 6th edition. I did not create this problem, but I found it on the book, and the book shows the answer but doesn't show you how to find the answer. So I thought, why not explain how to get the answer on a problem like this. So let's start. The most important thing is to know what is being asked. So what's being asked here? It's saying that for every A, we want 3 B's. So we must construct an NPDA diagram that produces that outcome. Not only that, but it must produce an outcome like this, where we have 2 B's and around 6 B's. So let's keep that in mind. So we want to make 3 states. Trying to make it neat, but that's not happening. And why we want 3 states is that this one will construct the A's. Going here and going to this state will make the B's, and then this is just the end state. So that's my logic here. This is like a 3-step problem. Make the A's, make the B's, then finish right here. So let's erase those. Now, what we want to do is, before we start, we want to write down what our word is and then what's on the stack to keep track of what's going on in this problem. I should make that smaller because this problem will take quite a bit of space. But don't worry, it's not too hard. So when we start, we want to input A as our first word. We know that. We want to input A. So we're going to write something on the top right here that inputs A and then gives us, to avoid confusion, I'll be using capital letters for the stack. We have a Z on the stack because we always start with a Z on the stack. You don't need a Z perhaps, but that's how the book teaches it, that you have a Z. You can add in anything, but you just need to know that you add in something on the stack that's different from everything else. So we always do Z. So a Z always gets added, and I'll be using small letters to indicate the word and big letters to indicate what's on the stack. So that being said, we will be taking away a Z from the stack and adding in 3 big A's and take in a Z. So what this does is that this first Z right here, that says let's take a Z off, all right? And now these right here say we add in 3 A's and a Z. So that Z, it stays there. The Z stays there. So what happens in the end, we just add in these. And let's erase this S right here and put it more over here, as we will be adding quite a few things onto the stack. Let's erase that. So this is what we have so far. We input an A as the word, and we get 3 A's and a Z on the stack. Now there's more stuff that we can be adding right now, but let's just move on for now. We move on. When transitioning from, let's just name these states. It doesn't matter what you name these, but that's what we're calling them. When you go from the start state and you move on to the D state, let's just write that D neater. That does not look good. What we want to do is say, hey, let's put a B as our word that takes away an A, that takes away a capital A to avoid confusion, takes away a capital A and adds in nothing, a lambda. So when going on this pathway, what that does, it adds in a B to our word and takes away a capital A from the stack. So far our word is A, B, and our stack is AAZ. Now, once you're here at the D state, this will loop around, and what you want to do is have the word B that takes away an A from the stack and adds in nothing. So you loop this around however many times you need, and you end up with B takes away an A. You loop around once more. You add in a B, take away a capital A, and boom. Now you must progress onward. Nope, don't want to do that. And we must progress on, And since we only have a z in the stack, the only thing we could do is do nothing that takes away a z and adds in a z, and that gets us to the final problem. So this right here, this graph, this NPDA, it accepts A, B, 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 B. Did I say that right? A, B, B, B. But it only does that. We need to make a few adjustments to future-proof this. What if we want to add in 3 B's? What if we want to add in 4 A's or an infinite amount of A's? What we want to do is make this guy loop around. Let's just erase what we got here. Start from a clean slate. We want to make this loop around, and we want to add an extra little line here. I'm sorry if that's in the way. I could move this. Can I move this up? I don't know how. I'm sorry. What we want to do is when we add an A to the word, it takes an A off the stack, but adds in 4 A's. So what this line does, it adds in an A on the stack. It takes away an A, but we already have 4 A's being added. So in reality, there's a net gain of 3 A's being added to the stack. So you have 4, we cross 1 off, we have 3. We can then run this line, We can then run this line again. We have another A, we add in 3 more big A's. And let's just say we're done. And we move on. Let's erase these highlighters. And we run this line and then this line. This basically says for every 1 A, we add in a B. So then we do this. Oh, whoops. Don't want to do that. And you see how this comes out. We have 2 A's and we end up with 6 B's. We can just erase all of that, cancel all of those off of the stack. We have Z on the stack, and we can move onward. But we're not done yet. What if you don't want to do anything? What if you don't want to do anything on here? We need to add one more thing. We need to add, let's erase the highlighters. We need to add something right here. And what that is that it adds a lambda on to our word, which means nothing. It takes a Z, but adds in a Z. So if we use what's highlighted here, and then this right here, and this is a lambda, not an X. Sorry about that. We basically get nothing from going here to then here, nothing. That is the answer when you do this. You got to be careful when constructing these. I just want to make sure I have everything right. I do. If you go right here, this is a more neater example of the chart. This is what's in the book. This is just me showing you how to do the problem. So that's it. Thank you for watching. Like the video, and see you later.